बिस्मिल्लाहिर्रहमानिर्रहीम। शुरू अल्लाह के नाम से जो बड़ा मेहरबान निहायत रहम करने वाला है। This is your chemistry teacher, chemistry first year. Today we are going to discuss about and learn about your unit number 5, your book, first year chemistry book, chapter number 5, that is liquids. In today's lecture, after the points discussed, you will learn to able about the introduction of liquids. KMT stands for kinetic molecular theory of liquids, properties of liquids, dipole forces, London dispersion forces, and hydrogen bonding and its applications. Here is the introduction of liquids. What are liquids? A simple definition of a liquid is that it is a material that assumes the shape of a container without filling it completely. It is a material that assumes the shape of a container without filling it completely. Here is the different states of matter. Number one is solid, next is liquid, and other is gases. There is a comparison of properties of solid, liquid, and gases. Here solids are rigid, the liquid particles are not rigid, and the gases are also not rigid. The particle distribution is that the solid particles are closely together, liquid particles are randomly arranged but have clusters, but the gases are more random arranged and have a large distance between the particles of a gases. Solids have fixed shape, liquid had no fixed shape, and gases also have no fixed shape. The solid particles have fixed volume, liquid also have fixed volume, but gases have no fixed volume. Solids cannot be squashed, liquids cannot be squashed, but gases can be squashed. This is the introduction of a liquid, solid, and gas comparisons. And a liquid is a material that assumes the shape of a container without filling it completely. Here is the postulates of kinetic molecular interpretation of liquids, that is KMT of liquids. The postulates are: number one is a liquid is made up of molecules which touch one another. The liquid molecules are close together, that they are in a form of clusters. Number two is the molecules within the liquids are in constant motion, but the movement of molecules is restricted due to their close packing together. Number three is attractive forces among liquid molecules are greater than those among gas molecules. Gas molecules particles are very apart from each other, but the liquid molecules are close together. However, these attractive forces are not sufficient to hold molecules in a fixed position. The molecules can slide each other. The next is the average kinetic energy of liquid molecule is directly proportional to the absolute temperature. Next is at constant temperature, the average kinetic energy of molecules is equal to the kinetic energy of the vapors of liquids. Now we will discuss about the properties of liquids. There are some simple properties of liquids. For example, number one is diffusion. Number two is compression. Compression means effect of pressure. Next is expansion, that is effect of temperature. Next is motion of molecules, spaces between them, intermolecular forces. The last one is kinetic energy based on kinetic molecular theory. We discuss all these properties on the basis of kinetic molecular theory. Number one property of liquid is diffusion. What is diffusion? What is the concept of diffusion? The diffusion in liquids take place because the molecules move from one place to another due to kinetic energy. The restrict movement of the molecule reduces the rate of diffusion. The diffusion is that the transfer of molecules from higher concentration to lower concentration. But in liquid, the diffusion is restricted due to the cluster formation of liquid. The force of attraction between the liquid particles is much closer. For example, a drop of ink when added to the water diffuses slowly due to the relatively small empty spaces between the molecules. The diffusion between closely packed molecules of a liquid is slow due to the less collision between them. Here is the example. Here is a simple glass of water. If we put a drop of ink in it, then slowly it diffuses throughout the glass and it becomes a blue. Here is the slow process of diffusion occurring. This is the best example for diffusion. The next is compression, means effect of pressure. A liquid cannot be compressed significantly by increasing the pressure because molecules are already in close contact with one another. An increase of pressure from 1 to 2 atmosphere reduces the volume of water to 0.0045%, which is negligible, which is not countable. However, the same pressure reduces the volume of a gas up to 50% because the gas particles are very far away from each other, but the liquid particles are close together, so there is no effect of pressure significantly on a liquid. Here is the example that the piston and the cylinder. Piston, pressure applied on this piston is a gas particles. These gas particles are easily compressible, but on liquid particles it is not compressible. In solid it is also not compressible. The next is expansion, means effect of temperature. The liquid expand on heating because the intermolecular forces between them decreases. When a liquid gets heat, the particles of a liquid moves far away from each other. That's why the intermolecular forces between them decreases. Moreover, the increase of temperature increases the effective collisions between the molecules. If the temperature is decreased, the contraction of molecules take place. This property is useful for making thermometers. In thermometers, when you have a fever, it liquid expands, and when you have not a fever, it liquids contract. For example, mercury thermometer is a good example to explain expansion of a liquid. In it, if the temperature rises, the mercury expands in the capillary tube. As the volume of capillary is much less than the volume of bulb containing mercury, a small expansion gives a large movement of mercury thread. Here is the example. Thermometer. Okay. Here is when you heat up a liquid, it expands and comes to over. This shows that the water expands on heating. The next is motion of molecules. The molecules move with lesser speed due to the larger force of attraction among them. As a result, they have lesser kinetic energy. However, the kinetic energy increases with the increase of temperature because it have a direct relation with kinetic energy and temperature. In a liquid, molecules are in constant motion. There are appreciable intermolecular forces, molecules close together. Liquids are almost incompressible. Liquids do not fill the container. The spaces between the particles of liquids. The molecules forming the liquid state are fairly close to each other. Again the same thing, again the same repetition, again the same concept. The molecules of a particles are close together. There is a very little space between them. As a result, the number of collisions among the molecules are moderate. Therefore, the average kinetic energy is also moderate. Here is the solid state particles very close together. Here is a liquid state particle in a cluster form but close together. But in a gas state, their particles are far away from each other. The next is intermolecular forces. The attractive forces existing between the individual particles of a substance are called intermolecular forces. The physical properties of a liquid, such as boiling point, vapor pressure, surface tension, viscosity, and heat of vaporization, depends upon the strength of intermolecular attractive forces. If these forces are strong, the physical properties have a high and low concept. Here is the solid. Kinetic energy increases from solid to liquid, liquid to gases. Okay. Force of attraction themselves particles is decreases. Gas has maximum. Liquids मतलब force of attraction between particles increases from gas to liquid and liquids to solid. Next is, according to the kinetic molecular theory, the molecules due to strong intermolecular attractions have minimum movement and minimum collisions. Let us consider the example of water. As the molecules are closer to each other and have a strong force of attractions due to hydrogen bonding, have a low kinetic energy. The next is intermolecular forces, means van der Waals forces. The force of attraction among the molecules of a liquid are called intermolecular forces. Water exists as a liquid due to the intermolecular attractions called hydrogen bonding. Hydrogen bonding is an example of intermolecular forces. The force of attraction existing between the molecules of a substance are also known as van der Waals forces. The molecular name for intermolecular forces, another name is van der Waals forces. Types of intermolecular forces. The physical properties of a liquids can be explained in terms of their intermolecular forces. The intermolecular forces are of 5 types. Number 1 is dipole-dipole forces, ion dipole forces, dipole-induced dipole forces, London dispersion forces, and hydrogen bonding. Now each intermolecular forces are discussed in detail. Number 1 is dipole-dipole forces. Here is di means two and pole means two different poles, partially positive and partially negative. The attractive forces between the positive end of one molecule with the negative end of the other molecule are called dipole-dipole forces. Force of attraction between two opposite poles are called dipole-dipole forces. This means dipole-dipole interactions are electrostatic interactions between permanent dipoles in a molecule. Here is the example. Here is the one molecule, that is hydrogen chloride. Hydrogen is partially positive, chloride is partially negative. Here is another molecule of hydrogen chloride. Here hydrogen is partially positive, chloride is partially negative. The force of attraction between the positively charged particles, that is chloride negative and hydrogen positive, is called dipole-dipole forces. Example of polar molecules include hydrogen chloride, chloroform, acetone, etc. Force of attraction between oppositely charged end of polar molecules. The strength of the dipole-dipole force depends on the polarity of the molecules. Stronger these dipole-dipole forces, greater would be the value of thermodynamic parameters like melting point, boiling point, heat of vaporization and heat of sublimation. Means have a strong force of attraction between the two different dipoles, have a strong values for melting, boiling and heat of vaporization. The next is London dispersion forces. The force of attraction between the non-polar molecules. It is the concept for non-polar molecules. Behind the previous slides we discussed the dipole-dipole movement for polar molecules and London dispersion forces for non-polar molecules, which becomes polar for an instant, are called London dispersion forces. Here is the London dispersion forces concept. At that instant, then the helium atom is polar with an excess of electrons on the left side and a shortage on the right side. Here is the subatomic particle view at atom A and atom B. Here is the nucleus and here is the electrons. When polarization view, here all the electrons come to the next atom. Substances like hydrogen, helium, neon, argon, chlorine, fluorine, methane, etc. are non-polar in nature. These gases can be liquefied and solidified under appropriate conditions. Some forces must be holding these molecules in contact with one another in the liquid and solid state. The force of attraction between an instantaneous dipole and induced dipole are known as dispersion forces. It is also called as London dispersion forces. The next is factor affecting the London dispersion forces. Number one factor which affect the London dispersion forces are atomic or molecular size. The strength of London dispersion forces depends upon the size of the electronic cloud of the atom or molecules. With the increase in size of atom or molecules, the dispersion becomes easy and these forces become prominent. Inert gases are all the monatomic gases. They do not make covalent bonds with other atoms because their valence shells are complete. They are zero group elements. Their boiling point increases down the group from helium to radon. This is because of increase in molecular size. The next is polarizability. The polarizability of an atom or a molecule is a measure of the ease with which electron charge density is distorted. Large atoms have more electrons and larger electrons cloud than small atoms. For example, among the halogens, the first member fluorine is a gas at room temperature. The second member chlorine is a gas but it is more easily polarizable than fluorine. Bromine is a liquid and iodine are solid at room temperature. Because the larger molecules are easily polarizable, the intermolecular forces between them are strong enough to form liquids or solids. Number 3 is number of atoms in a molecule. Elongated molecules make contact with neighboring molecules over a greater surface than do small molecules. Greater the number of atoms in a molecule, greater is the polarizability of the molecule. Next property is hydrogen bonding. It is the simplest definition of hydrogen bonding is that hydrogen bonds are attractive forces between the hydrogen attached to an electronegative atom of one molecule and electronegative atom of the different molecules. Hydrogen needs to be attached to a highly electronegative oxygen, fluorine, nitrogen and atoms. इंटरमॉलिक्यूलर फोर्सेस में हाइड्रोजन बॉन्ड है, हाइड्रोजन बॉन्ड फॉर्म बिटवीन टू मॉलिक्यूल्स. इंट्रामॉलिक्यूलर हाइड्रोजन बॉन्डिंग, हाइड्रोजन बॉन्ड फॉर्म बिटवीन टू डिफरेंट एटम्स इन द सेम मॉलिक्यूल. Intermolecular hydrogen bond is stronger than van der Waals forces. Hydrogen bonds are weaker than covalent bonds but stronger than dipole-dipole interactions, which are stronger than London dispersion forces. The next is applications of hydrogen bonding. Applications of hydrogen bonding. Number 1 is thermodynamic properties, solubility of hydrogen bonding, cleansing action, hydrogen bonding in paints and dyes, clothing, food materials, hydrogen bonding in biological molecules. Each application will discuss in detail in the next slides. Number 1 is thermodynamic properties. The boiling points of the hydrides of group 4A, 5A, 6A and 7A plotted against period number of the periodic table is shown in the figure. Here is the figure. Note that the hydrides of group 4A have lower boiling points. 4A have lower boiling points. The reason is that these hydrides are non-polar and have only London dispersion forces among their molecules. Hydrides of group 5A, 6 and 7A have molar molecules, that is ammonia, water and hydrogen fluoride, show maximum boiling points in their respective series. This is due to the hydrogen bonding in their molecules. Next is solubility of hydrogen bonded molecules. The compounds that have hydrogen bonds are soluble in each other. For example, ethyl alcohol can dissolve in water because both can form hydrogen bond with each other. Similarly, carboxylic acids are also soluble in water if their molecule size are small. This is all because of hydrogen bonding. The next is cleansing action. Soaps and detergents perform the cleaning action. Their molecules contain both polar and non-polar ends. Their polar parts are water soluble due to the hydrogen bonding, and non-polar part dissolve oil or grease. Attraction between water and polar end of the soap molecule carries the oil or grease droplet to the water. Cleansing action is due to the hydrogen bonding. Solubility is due to the hydrogen bonding. Next is hydrogen bonding in paints and dyes. Paints and dyes have an adhesive action due to the hydrogen bonding. Similarly, hydrogen bonding also makes glue and honey stickle substances. Clothing. We use cotton, silk or synthetic fibers for clothing. Hydrogen bonding is one of the great importance in thread making materials. This hydrogen bonding is responsible in their rigidity and tensile strength. Next is food materials. Food materials like carbohydrates consist of glucose, fructose, sucrose. Each of them contains hydroxyl group, which is responsible for hydrogen bonding in them. The structure of proteins, substances essential to the life, is determined partially by hydrogen bonding. The action of enzymes, the protein molecules that catalyze the reactions that sustain life, depends in part on the forming and breaking of hydrogen bonds. The hereditary information passed from one generation to the next is carried in nucleic acid molecules joined by hydrogen bond into an elegant structure. These are the long applications of hydrogen bonding. This is all about the applications of hydrogen bonding. Have you got all the points? Have you cleared the concepts? Thank you very much, students, for your attention. If you feel any query, you all feel free to ask. Allah Almighty bless you all. Thank you very much. Take care. Allah Hafiz.